Lesson 3.13, Angles and Polygons, Part 2. The objectives in this lesson is to find the measure of each interior angle of a polygon, to find the measure of each exterior angle of a regular polygon, and to use properties of polygons to solve problems. The term that we're going to be using primarily in this lesson is regular polygon, and remember that's a polygon that's equilateral and equiangular. First, we're going to start out by filling out this table, and instead of putting the name of the polygons, I just put a picture of them so we could work with it a little bit. In this first one, let me get my pen ready. Okay, and this one says the number of exterior angles. Well, we figured that out earlier, but remember I said that in a future lesson, oops, I don't want to do it that way, that we would only be using half the exterior angles. Let me come over here and do insert. I got this all fixed up for me so I can show it to you perfect. There we go. And then I'm going to add another one. Remember, you do this for each side. And then I got to do one more. There we go. So now we can see that we have a triangle that has 3 exterior angles. And the sum of the measures of the exterior angles will always be 360. Okay, always. Now if you'll remember, remember it's a regular. Well, this isn't regular. I wasn't thinking about it being regular. And I'm talking about this quadrilateral down here. Let me write on here, not regular. Okay. The sum of the interior angles of a regular equilateral triangle, or equiangular, is 60. Well, remember the linear pairs tells me that angle 2 here is going to equal, you got 180 minus 60 is going to give me 120, right? So this one has to be 120 degrees and angle 1 has to be 120. Well, 120 times 3 is going to give me 360. And that will work with your quadrilaterals, pentagons, all of your gons. All of them will add up to be 360. So you can even be so bold as to go ahead and write 360 in there. And this right here isn't supposed to say sum, that should say measure. Measure of each exterior angle. So I've already figured that out. For this one is 120. But see, the operation that I did here was multiplication. Okay, so I can figure out the measure of each exterior angle by taking 360 and dividing by the number of sides, which in this case was 3. So if I got a quadrilateral, usually these would be regular, but this is going to work for us. Let me go to this shape. Let me go over here and add this. Let me add another one. Oops, I clicked the wrong one. Oh, I must have unclicked it. There we go. There it goes. And let me put another line right here. Oh goodness, I think I did click the wrong one that time. That came out something real crazy squiggly. Let me line that up a little better. It's not going to line up any better, but y'all can see what it's going for. There we go. And so if I come back over here, I can count out my number of exterior angles as 4. And if I wanted to figure out, remember, they're all going to add up to 360. Now remember, if this was regular, like if it was a rectangle, remember all those sides right there equal 90? Well, my exterior angles are also going to equal 90. Just like that. So remember what I did earlier? I said, okay, if I had 90 times 4, that's going to give me 360. But if I wanted to use a formula to figure it out, I'm going to put 90 degrees right now. I would say 360 divided by the number of sides. Remember that little e means measure of external angle. So for the pentagon, it's got 5 sides. So I would come over here and I would say, okay, 360 divided by 5. And that equals 72 degrees. Now, remember, if I was to come over here and add my arrows like that, and remember how you find out, I don't think we had found out what the interior angles were, but I can say 360 divided by 5, and I know that this exterior is going to be 72. Okay, and we got just a couple more that we're going to look at here. If I can find my little clicker. You've got the number of exterior angles is going to be 6 for a hexagon. It's going to be 7 for a heptagon. Remember, your sum is always going to be 360 degrees. You can always say 360 divided by 6, and that's going to give you the sum of the interior angles, which is going to be 60. I mean the exterior angles, not interior. I can come down here and I can say 360 divided by 7. And this is going to be my first crazy looking decimal. My exterior angles is going to equal approximately, not an equal sign, you have to approximate, 51.4 degrees for each external angle. Now what we were going to do here was, you've got your anagon, you've got your number of angles or sides, which is going to be the same thing. Here we have the sum of the measure. So if I want to find the measure of any gon, that's how I would do it. So let's go with that 20 gon again, like we did in our last video. I just do 360 divided by 20, and I would get that each exterior angle is 18 degrees. Okay, so there's the full chart showing you what it looks like. And you'll notice the number of exterior angles always matches up with the number of sides. The sum of the measure is always 360, so I can always take the 360 divided by the number of sides to figure out what the measure of each exterior angle is. Alright, this slide says determine the type of polygon for the given sum of measures of the interior angles. And so for this first one, it says 900 degrees. I got 900 degrees, so I got to determine, based on that sum of the measures of the interior angles, I got to figure out what kind of polygon it is. So remember our formula. We had 180 n minus 2 equals the sum of the interior angles. Okay, so I just got to plug in this information that I'm given, which is the 900. I'm going to plug that in for the sum of the interior angles, and now I'm going to have to distribute this 180 to everything in the parentheses. So I'm going to have 180n minus 360 equals 900. I'm going to add 360 to both sides. So I'm going to have 180n equals 1260, and then I'm going to take that 1260, I'm going to divide it by 180, and I get 7. So this is a heptagon, because remember the n equals sides, so there's 7 sides. Alright, in the second one, I'm going to have the same formula. It says the sum of their interior angles is 2,520. So I've got 180 n minus 2. I'm going to replace that sum with 2520. I'm going to go ahead and distribute my 180. And then I'm going to add 360 to both sides. I get 180n. Oh, I got to put that one in a calculator. That's a big number. 2520. That's going to be 2880. And then I'm going to divide that by 180. I didn't show this step in the other one, but I hope y'all knew what was going on. So that's 16 sides. Oops, ran out of space. So that means it's a 16gon. There's an official name for it, but they don't expect you to know them after dodecagon, which is 12-sided. And there's your answers. They did a little different. They divided both sides by 180 right here, and that's fine if you want to do it that way. Okay, this slide says determine the number of sides of a regular polygon for the given measure of one of its interior angles. Now, something that we haven't talked about is how do you find the sum of just one interior angle? Well, we know how to find the sum of all of them, right? So if I take that and I divide by the number of angles in the polygon, which corresponds with the number of sides, that's going to give me the measure of one interior angle. So what I'm going to do here for this one is I'm going to say, okay, I got this little I equals 180 n minus 2 divided by n. So I have 180 n minus 2 over n, and look at me, I just wrote the formula all over again. I forgot to plug in what I knew. 140 for the measure of one interior angle. Now hopefully y'all remember this trick from when you were learning about fractions, or in algebra you always got to get variables out of the denominator. Actually, you just want to get rid of the denominator altogether. So if I multiply both sides of my equation by n, which is the denominator, it cancels out on this side. So I end up with 140 n, equals 180 n minus 2. So I got 140 n. I got to distribute this. So I have 180 n minus 360. Got to get my n's on one side. I prefer them to be positive, but it just didn't work out with this one. So you see 140 minus 180 gives me a negative 40n. Divide both sides by negative 40. So I'm going to have n equals 360 divided by 40 equals 9. And that's 9 sides. So this, I hope I have enough room, is a nonagon. That's what we call a non-sided polygon. Alright, part B, they tell me one interior angle is 172. So, I got my formula. And I'm going to plug in what I know. I'm not going to write the formula again, which is 172. And I'm multiplying both sides by n, so I can get that n out of the denominator. And it doesn't really cancel, it just reduces to 1. So I have 180 n minus 2. I'm going to distribute my 180. Then I'm going to subtract 180 from both sides because I want to get all my n's on one side and have my constants on the other. So that leaves me with 6n, I believe, or 8n. And that gives me 360. I'm going to divide both sides by negative 8. So I end up with n equals 45. Woo! So 45 sides. So that means this is a 45 gon. 45 sided polygon. That's big. Here's your official answer. For A, n equals 9. It had 9 sides. That's what I came up with. For part B, had 45 sides. Kind of showed you here how I worked it out. Okay, this slide, it's our last example, says determine the number of sides of a regular polygon for the given measure of 1, that's a key word right there, 1 of its exterior angles. Okay, we remember that the sum of them is 360. So the sum of all the exterior angles is 360. And remember, if I wanted to find the measure of one side, that's what I did in the chart earlier. Okay, so I've got A. E is 360 divided by n. I know that E is 3. I'm going to multiply both sides by n to get it out of the numerator. So I have 3n equals 360. Remember, those reduce to 1, so they're gone. I'm going to divide both sides by 3. And that gives me 120. So it has 120 sides, 120 gon. Wow, that's just almost circle, I bet. Okay, part B, each exterior angle measures 11.25 degrees. So I'm going to have 11.25. 360 divided by n, that's a 6. I didn't want you to freak out and not know what it was. So I got to end up with 11.25 n equals 360. Remember, these guys reduce to 1, so they disappear. divide both sides by 11.25. I got n equals 32. 360 divided by 11.25 is 32. So it's a 32-sided polygon, which is a 32gon. There you go. To summarize this lesson, we know that the sum of the measures of exterior angles of a convex polygon is always 360. A regular polygon has congruent sides and angles. This is how we find the measure of each exterior angle, and then to find the measure of each interior angle, we can use the formula this way, or we can use it this way. Whichever one you prefer. They both work. Like always, you need to go through and complete the read through the LMS and complete the student guide. Read pages 85 through 88 in your reference guide, and complete problems 25 through 30. And you only need to do parts A and B, because several of them have a lot of parts. You just need to do A and B. After you get finished with those, please attend TOGA or contact me if you have any problems understanding the concepts before you complete the quiz. And this is it for lesson 313. Thanks for listening.